Alright, so now we're moving on to 10.2, areas of trapezoids, rhombi and kites. Now don't forget, each one of these will have its own distinct formula. So, going on what we've always done, formula, line of working out and answer. Okay, well here's the formula for a trapezoid. It's a half times the perpendicular height again, and B1, B2, and it doesn't matter which way you put them round because you're going to add them together before you multiply. But normally B1 is the shorter side and B2 is the longer side. And don't forget, the properties of a trapezoid is that you must have perpendicular sides. Okay, and don't forget the perpendicular height may be on the inside, maybe on the outside, but again look for Pythagoras, special right triangles, or even trigonometry to find the perpendicular height. Okay, so now we're looking at example 1 into real world examples. Again, we've got what is a purse here. B1 is 28, B2 is 58, and the perpendicular height is 30. Quote the formula, line of work out, and put your answer. And don't forget, area is square units. And as you can see with example 2, sometimes you have to put the auxiliary line in again. Okay, here's your shape you started off with, but you've got to make that. You don't know what this extra height is or the width of whatever this is, but as you can see, you know that the whole length is 10. You do know that the height is 4, and you do know that the hypotenuse is 8.5. So using Pythagoras, you find whatever L is, and then you can work it through from there. Alright, but again, you finish up with your half base 1 plus base 2, and you come up with your solution. Alright, so before we do any examples, we're moving straight on to rhombus and kites. But the one good thing about rhombi and kites is that you've got the same formula for both. Alright, it's diagonal 1 times diagonal 2 divided by a half, or a half d1 plus d2. Okay, but again, look, don't forget, when diagonals of a rhombi and kite, they will cross at right angles. So you know at some point or other you may need to use Pythagoras. Okay, so here's example 3. The first one is relatively easy. Okay, you've got the area of a kite, you've got one diagonal, you've got the second diagonal, so you can just put it straight into the formula, line of working out, and an answer. But again, make sure you read each one, because now we're talking about they bisect each other, and the lengths of the diagonals are 12 plus 12 and 10 plus 10. So you may have to do an extra little bit of work in order to find out the fact that it's 24 times 20 and then multiply by a half before you can come up with your correct answer. Let's have a look at a few of the examples. All right, we'll do one of each. So question number 1. Is your trapezoid. So A equals your half times your perpendicular height, B1 plus B2. Okay, make sure you quote the formula first. So A is going to be whatever a half is times 12. And I'm putting everything in parentheses that I need to. And B1, and the smaller one, is 6. 6 plus the 16. Okay, so that's going to give you 12 times 22 divided by 2, and that will give you the area, and the area, which will give us 132. Okay, and don't forget, it's whatever it is, and this is feet squared. All right. Okay, I'm going to skip over to number 3 now. So that was number 1. Let's have a look at number 3. Okay, so A is equal to a half D1 D2. Okay, so equals the half D1 in this case, and it doesn't matter which way it goes around because it's being multiplied, so that's going to be 17. D2 is going to be 21, and if you put that into your calculator and solve, you get 178.5, and now we've got units, which is meters squared. And as we know, we always go tricky. So here's example 4. Now we don't know the dimension, so we're basically back to algebra. But make sure you read the statement first. One diagonal of the rhombus is twice the length of the other. Okay, so Here's the formula that they're quoting straight away. You do know the area is 169, and now replace D1 with D2. Well, if you make D1 X, and don't forget the other length needs to be twice as long, so this needs to be 2X. So when you multiply them all together, okay, so you've got an X times 2X is 2X squared. A half of 2x squared is just x squared, and then you square root your answer. So x must be 13, so this must be 13, and 2 times the 13, that means that must be 26. So make sure you read the statement first. Is it going to be a half? Is it going to be twice as much? Or whatever it could be, whatever multiple it is. And before we go on to the final set of examples, here are all the formulas that you will need. Again, it's one of these that I feel that you should screenshot, copy it, put it where you can remember it. Eventually you will be using it again later on. Okay, so let's have a look at one of those. So let's pick number 5, the trapezoid. Don't forget the formula is A equals a half times whatever the height is, and then B1 plus B2. So there's the formula. So your next line of working out is just substituting what you've got. So 78 equals 1/2. We don't know what the height is, but I'm going to put that in parentheses. B1 is 6.4, and you've got to add on to that your 13. Alright, so you know me, I like to get rid of things that I don't like, so I'm going to get rid of the fraction first. So if I multiply both sides by 2, the fraction will disappear. So 2 times 78 would be 156. The half has now disappeared, and if I add 6.4 and 13, I get 19.4, and that is H. Okay, these guys are multiplying each other, so I'm going to divide, so I'm going to rearrange it as well. So H equals 156 divided by 19.4, and if you put that in your calculator, you will get 8.04. Okay, and just simplify that down to a whole number, and that will be 8.